Today, we're moving away from our normal hands-on approach to focus on design, specifically on how to design in the necessary features into your patterns to go on to produce molds for successful composite parts. By the end of this video, you're going to have a good understanding of trim allowance, mold flanges and returns, where to locate parting lines, and how to add in other features such as integrating mold clamping bushes in multi-piece molds. Before we jump onto the computer though, let's go over some of the fundamentals to make sure that we're all on the same page. So let's say that this carbon fibre engine cover is the final part that you want to create. In order to make this, you're going to need a mould. This is the mould for the part, and as you can see, if we drop that in, this component has been formed in this mould. Now, in order to make the mould, we essentially need another mould, and that's what we've got here. This is the pattern. This has been CNC machined from epoxy model board, and if I loosely drop the component over the top of this, you see we've got exactly the same shape, but we have a lot of additional material and features, and it's the design of these features that will be the focus of this video. We have these blanked off areas where we've got apertures. This would be the same if these were drilled holes, and then if you look around the perimeter, we do have a slight extension that runs all the way around the outside. This is what's known as trim allowance. It simply allows you to mold the component oversized and gives you the room to accurately trim it down to final dimension. Beyond the trim allowance, we have the mold flange. This is there to stiffen the mold and also means that any excess material will easily release from it. And then in the case of this mold, we've also got an optional return as well, and this just further stiffens the mold up. So that about covers all of the features that you're likely to see in a simple one-piece mold. We will be looking at much more complicated split molds shortly, but before that, let's jump onto the computer and design in some of these features. This video is not intended as a CAD modelling tutorial, and so it does assume that you've got some prior CAD experience. If you haven't, then there is loads of information out there to get you started. The software I'm going to be using is Fusion 360. The sole reason for this is I know that this is the package that a lot of you out there are already using and already familiar with. But as I'm only going to be using very generic tools and methods, everything you see me doing would be applicable to any engineering CAD software, whether that's Catia, Solidworks, Onshape, anything like that. One more thing that's worth mentioning is that some CAD packages will have inbuilt functionality or extensions for mold design. Now these are primarily going to be targeted at injection mold tooling, and so they don't really translate that well to pattern making in composites. But if you do have access to them, by all means experiment with the functionality, as sometimes you will find that they'll offer shortcuts into things like defining your parting lines. More often than not though, I find myself manually designing these elements in anyway. So let's get started and open up our file. So the file type that I'm opening up here is a step file. That's quite typical of the sort of file that you would be sent by a customer. But of course, if you've modeled it natively in the software, then obviously work from that fully featured model. So this is the model of the engine cover. The thing that I want to do now is establish whether this is going to release effectively from a mold. So we're going to consider the draft angle. In composites, any draft angle over 3 degrees is not going to cause any problems to release at all. Now, for small areas, you can go steeper than this, almost down to 0 degrees, particularly on like the edge of a tube molding. So what we'll do now is go on the Inspect tab, select Draft Analysis, select our body, and then choose the direction that we will be pulling the part out in. So we're going to select the Z plane here, as that's the direction that we'll be likely pulling. So to get our draft angle set here, we're going to set 0 degrees and 0.5 in the draft angle. Then we're going to have a tolerance of 0 and 2.5. And what this is going to do is highlight any areas that are less than 0.5 in red. They're likely to be problematic areas. Any areas that are less than ideal in yellow, and then any areas that are perfectly fine in green. Now we can't really see much on this because this model actually has very generous draft. You'll see a small area of yellow just in this area here, and that might be down to the orientation of the model. But if we were to change the direction of pull to say the side one here, not that we would ever try and pull it out of the mold there, you can see more clearly what that would look like. So we'll now set that direction back onto our Z-axis and click OK. Our draft analysis is still in place here. We've got those small problematic areas at the side, but if we just take on a side view, we can see that this model has quite a steep angle to it, and we can level this out, and this is going to do two things. One is it's likely to fix that small area of draft that we've got there, and the second thing is that it's going to use less material in the pattern, so we're going to just flatten that out. So we'll just select the body and move that round, just setting the angle round to bring it in level. 5 degrees, if I just cheat and use the bottom edge, that looks about right to me and approximately level, so we'll just click OK on that. And then if we now just pan around the model, we can see that we've now got no undercuts showing on that draft analysis. With everything set up, we can now go on and model in our first feature. That's going to be the trim allowance, or the extension that runs all the way around the perimeter of the part. So I'll just move in here and select one of these edges, and then in the surface tools I'm going to create a ruled edge. On the edges that I've got selected, I'll just select 2 or 3 of those, and then change the type to direction, and then set the direction as the Z plane, so they're just drawing straight down. In terms of the length of this extension, for pre-pregs this could be really anywhere between 3 and 10 millimeters. But for hand layup or resin infusion molds, you might want this to be quite significantly larger. So I'll just set that to -4 millimeters, and then I also want to add in a draft angle. I'm going to put in a draft angle of about -5 degrees here, and that's just going to kick those flanges out, which means that they won't have a problem. Otherwise, if we just drew them straight down, we would have parallel sides, which we know would be a problem for release. So I'll now continue on and just select all of the edges on one side of the component. I only need to model these on one side as this part has symmetry, and so I can save a little time by mirroring these features over later. With the trim allowance modelled in, we can now move on and put the flanges onto the mould. Now for a pre-preg mould, these flanges can be just 50 millimeters around the perimeter, but for a resin infusion, this could be 100 or maybe even 150 millimeters to allow you the room for your sealant tape and vacuum bagging consumables. To model these in, we're going to create another ruled edge. And the first thing you need to do is determine what you see as the side of a component. And in this case, I'm going to be running this full length of the part and draw my flange out from there, and then I'll select this area as the front, and likewise the same thing at the back. So I've selected all of the edges down that side, and then we're going to create another ruled edge. And this time we're going to set our direction to the x-axis, and we've got 0 degree angle because these want to be coming out completely parallel. So in terms of the extension distance, 200 millimeters is more than enough. You can't do these too big at this stage because we are going to trim them back to size later. So oversizing them generally will be advantageous. So we're now going to continue and do the front and back. So on the rear here, if we just go in and select an edge right next to, it's very important that you do come right to that corner to meet the other side. So with those edges selected, we're going to create another ruled edge, and this time the direction is going to be the y-axis. And you can see that now that's extended, we've got the back of the part coming straight out from the back here. So I'll continue on and just get all of these edges selected. And then finally, we're just going to do exactly the same thing on the front. So we now have the extensions for the flanges out of the front, back and side of the component. All we need to do now is fill in these corners. That's really straightforward. All we need to do is select the edge, and then in the surface modeling tools, select sweep, and then for the path, select the other edge that you've got. It doesn't matter which order you do these in, the end result will be exactly the same. So we'll do that in that corner, and then we'll do the same thing on the back here. So we'll select sweep, one of the edges, select our path to be one of the other edges, and click OK. We now have the flange features for one side of our component, and we're going to mirror these over to the other side. Before I do that, I'm going to get all of these surfaces stitched together so it just becomes one body. So we select the stitch tool, and then select all of our faces and stitch them together. 0.5 millimeter tolerance would be fine on that, and click OK. Now that the surfaces are stitched together, we can simply mirror that over onto the other side. So we will select mirror, then our body, and then we'll use the X-plane as the mirror plane and click OK. So we now have all of those features around the part. The next thing that we're going to look at is blanking off the apertures that we have in the top of the part here. And this technique would be exactly the same if you had drilled holes in a component, which you will commonly find. So we're going to use the surface tools again, and then select patch, and then select the areas that we want to patch in. Just select that edge, it'll chain select the whole thing, and then we just click OK, and we have blanked those off. That's all of the fundamental features for a pattern modelled in. So we've got our trim allowance, our mould extension, and we've blanked off any features. So we can now use these surfaces to cut into some stock material that could be used to then create a pattern. To do that, we're going to need to stitch all of these surfaces together to create one single body. So we'll just select stitch, then all of the bodies that we've got there, and click OK. Now we're going to model in the stock material around this part. So we'll create a sketch in the top plane and draw a rectangle around this that's going to represent the stock material. So whatever size this is going to be was really going to dictate the size that the flanges will be on the component. In the case of this part, I want sort of 30 millimeters or so. So we'll just dimension these in at 230 millimeters. And here we'll go to 330. And we'll now extrude this out as a solid. So if we just come around to this plane here, we want to basically just bury our component just inside our stock material without excessive wastage. It can be quite useful to just change your style to wireframe here, just so you can actually get a visual on what's happening. So we just need the component just underneath the top edge of the stock there, and we can see at the bottom we still haven't completely buried it there, so we will extend out on two sides and draw on material underneath, leaving us enough material, enough stock there to give us some stability whilst machining. So we'll click OK on that. We'll return to our normal visual style. And now you can see our tool is running through the middle of that stock material. So now I'm going to use that tool to cut into that block. So we'll use split body, select the stock as our body and the tool as the surfaces that we've created earlier, and click OK. Right, so now if we hide our original surfaces and hide that other section of the split body, you can see that we now have our finished pattern shape, and that could certainly be machined as it is and used to create a mould. But I'm actually going to add in an additional feature. I'm going to put a return flange all the way around the perimeter of the main flange. And the reason for this is it just adds further strength and stiffness to the mould. To do that, I'm just going to edit the original sketch that I used to draw the stock. And then in here, I'm just going to add a perimeter around the outside by creating an offset of -25 on the outside. And then I'm also just going to put an offset on the inside, which will allow me to put a draft onto it, and you'll see that shortly. And then from here, we can now extrude. So we're just going to select the profiles that we've just put into the sketch. We'll extrude that a distance of around 40 millimeters. And then we'll also set it to extrude in two directions, so we come down to the base here. So just select that object, create a new body, and click OK. So we now have a perimeter flange all the way around the pattern. But what we have here is vertical surfaces, so we actually want to put a draft onto those. So we'll just use the draft tool, so modify, draft, select our pull direction, which is going to be the Z-axis, and then the faces that we want to put the draft onto. and we'll set a 5-degree draft angle onto those to make sure that we have no problems with the release. So we'll click OK, and then we'll combine these two bodies together to make them one piece. So that's our target body and our tool, combine, and so now we have a single body. The final thing I'm going to do here is just add some fillets into the corners. That's just because the tool wouldn't be able to access these sharp corners here. So we'll add a fillet in there. We'll put the fillets in at 10 millimeters. For this video, that's as far as we're going to take this component. The next steps would be to generate toolpaths and get this loaded onto a 3-axis CNC to be machined out of EB700 epoxy tooling board. Typically, the pattern would then be hand finished and sealed with S120 board sealer, which is then flatted out and polished before release agent is applied. The mould can then be laminated using surface and backing plies of Xpreg XT135 tooling prepreg, vacuum bagged and oven cured. Once cool, the mould can then be removed from the pattern, release coated and is ready to be put into service. And of course those moulds can then go on to produce parts like this. But we're now going to look at a more complicated example where we're trying to put in multi-piece split moulds. So let's take a look at that. In this case, this is the component that we want to produce. It's a fuselage for a fixed-wing drone, and clearly, with all of its complexity and two-sided nature, it's not going to come out of a single-piece mould. So these are the moulds that we have for this. This is the lower section of the mould, and so the component drops into there. Then we have these flanges here at the exact halfway point, all the way around the edge of the component, and then the upper mould locates onto that. And then in the upper mould, we also have this large aperture where the hatch is on the fuselage, and this just lets us get the vacuum bag into the component. Another feature of these is that we actually mould the wing roots at the same time. And to do that, we've got 90-degree flanges on these moulds, and then loose shuttering or loose tooling can be attached onto that to create that section of the mould. Another feature of these moulds is their use of MB6 mould clamping bushes. These metal inserts allow the mould sections to be accurately aligned and securely clamped together. In order to put these in on curved flanges like we have here, you will need to have flat areas. So we've got a male and female area on the moulds here, so we will need to machine those into the patterns. So if we look at the patterns then, the first thing you'll notice on these patterns is that they have this removable barrier around the perimeter. The reason for this is we want a 90-degree return flange on the mould. That allows us to attach that plate onto the side to form the wing root. We can't just machine this directly into the pattern at 90 degrees, as that would give us a problem with release. We just wouldn't have a draft angle. So instead, we machine it down at 90 degrees, and then this shuttering is then attached to the pattern prior to laminating. Another feature you can see clearly on these are the flat areas for the MB6 bushes. This is the male one in the pattern, which forms the female element on the mould, and then we've got its counterpart on the other pattern. We also have the flange around the aperture machined in. We can do it in this instance as we can afford a bit of draft angle on that. So let's jump back into CAD and get some of these features designed in. I already have the CAD model open here for the fuselage, and I've also opened up the model of the pattern. This is just going to be useful to cross-reference as we're going along. The first feature that I'm going to model in here is going to be the extension that we've got behind the motor mount that creates that aperture you've just seen in the mould. To do that, I'm going to first create a plane between 3 points on the back edge. So those 3 points will give me a flat surface to work from. Then I'm going to create a sketch onto there. In the sketch, I'm just going to best fit a circle onto the rear edge here. You don't have to be incredibly precise with this. And then we're going to extrude that. We'll be joining it into the rest of the body, and we'll just draw it out 50 millimeters out of the back, and we'll make that symmetric so it also fully joins into the rest of the component. Okay, so that's that feature added. What we're now going to do is do a draft analysis to look at where the parting line is and whether we have any problems with our geometry. So as we did before, we'll select draft analysis, we'll select the body that we want to look at, the direction, and then the tolerances that we want to work to. So again, it's 0, 0.5, 0, and 2.5. So we can see just at the back edge here, we've got quite an ugly feature here. Theoretically, this red line should represent where the parting line is, but in this case, the parting line would have to come up here, it would get broken, and then drop back down this edge. Now, that is going to be problematic. There's no way that you could actually machine the parting line to follow that. We could choose to ignore it, but then we're likely to have an undercut. So let's just see whether we can play around with the orientation of the model and get that improved. So we will just select the body we want to work on and move it and just play about with the angle. So at 5 degrees, kicking it forward, you can see straight away it does look better. Let's see what something like 3 degrees would look like. Now again, we've got quite an ugly area on the line here. So let's go back to 5 degrees. We're going slightly now underneath, so maybe there's a happy spot at about 4 degrees. Yeah, so you can see now that our parting line is coming in quite cleanly. You're never going to get something like this absolutely perfect, but this would certainly be workable at that. It might be 3.75. That's probably even better still. So you can, if we zoom in here, you can see that we're at the midpoint right the way through there. So that would be a good location for the parting line. Okay, so that's our orientation. We now want to add in the feature on the hatch that gives us that return, which is the aperture that goes into the mold. So on the pattern here, we're looking at this section. To do that, we're going to need to project some of the geometry from this slight rebate that we have around the edge of the part. This rebate to allow a hatch to drop in. So we'll create another sketch. We'll do it on the top plane. We'll capture our position. And then we will project our geometry. So then we'll select for the geometry the edge of the rebate all the way around. And we click OK. Now that we've got the projected features, we're just going to create an offset of these. So we're going to offset that around about 8mm inwards, and you can see that that's just giving us that line on the inside that's smaller than the hatch. And that just allows for that extra bit of rebate that we do have on the part here. So we'll click OK, and then we can extrude that feature. So we'll take that and pull it through our component. We then want to join, and we also want to put a taper angle because we can't have parallel sides, because again that's going to cause us issues for release. So onto that we'll stick for a -5 degree taper. There we are, and you can see straight away in the draft analysis that it looks absolutely fine. So this doesn't need to be quite as high as we've gone there. Something like that should be absolutely fine. In fact, let's just go to 70mm. Perfect. We're now ready to actually put in the parting line. As I mentioned earlier, some CAD packages will do this for you automatically or project that line onto it. But even if you have to do it manually like you do in Fusion, it's relatively straightforward. So we'll just take a side view here, and we can use our draft analysis as a reference for where that parting line is going to run. So we'll run a sketch in this plane, and starting out at the trailing edge, we'll run a line as close in on that parting line as we can get to. I generally find for parting lines like this, a spline tool is pretty easy to use, and just chase that line as closely as you can. As soon as you get off a curve, like we have done here, click OK, and then we will do the same thing and form a spline on the front edge. And just go through and adjust them as necessary until you're happy with their location. Then we'll just run that parting line through the centre there. And then we'll also extend out from the ends to create a flange detail. That's the parting line defined, and we can now draw a surface through where the parting line is going to sit. So we just go onto the surface tools, extrude, and select that line. And from there, we can just pull the parting line across. So we're going to do that symmetric, so it runs out both sides, and we're going to go just through to the edge of the component. We're now at the point with all of the features added that we can start modelling up the stock material. So we'll do a sketch on the top plane and just draw a rectangle around the edge of the component. So just nominally put that in. We'll align these edges. Then we'll just bring the dimensions in here to a nice round number as it makes cutting the stock that bit easier. Okay, so we'll now use this sketch to create an extrusion through our component to represent the stock. If we just switch over into wireframe, it's going to make that a bit easier to see, and we're going to be creating a new body, and we'll just draw it through the component like so. And we just need to fully encapsulate the part here. And that looks good to me. The stock now completely encapsulates our model. What we're going to do now is split that stock down the parting line using the surface that we created earlier. So we'll use split body. We're going to select that as our body to split our stock, and then the splitting tools, we're going to use that parting line surface. So we'll just click OK on that, and now we have two separate components. So you can see already that this is starting to look like the pattern with all of its features. So the next thing that we're going to do is actually subtract that model from that stock material, effectively creating the mold cavity that we want. So we'll use the combine tool, we'll select cut, our target body is one of the pieces of stock material, and then the tool body is the model itself. We're also going to select keep tools, as that means that we don't lose that model in this operation. Click OK, and then we're going to repeat the exact same process with the lower piece of stock. Now, if I hide the model itself, we have effectively the mold that we're looking to produce. So that's our full mold cavity, and we have the two individual components. Also notice that I've got an extra couple of bodies have been created here. I was only expecting two, so let's take a quick look at what we've got there. I can see those straight away. We've just got these additional bits. That's where the parting line has come through and actually cut into the other side of the tool. So what we're going to do is just join those back down onto the original part. So all we need to do to fix that is just select those bodies and combine them, join operation, and this time we don't need to keep those tools. Click OK, and we now have that as a single body. We now have what is basically the two mold halves modelled up. The next thing that we need to consider is how to accurately align and clamp these sections together. To do that, we're going to be using these the MB6 mold clamping bushes. The way that these work is they are located onto a drilled hole in the pattern using an extractable dowel pin. The bushes are then laminated around during the mold making process, which encapsulates the bush and provides a perfectly aligned and hard-wearing bolt location to allow the mold sections to be clamped together. Now, because we're 3-axis machining, and so any holes that we bore into the pattern will be vertical, we do need to make sure that we've got a flat perpendicular plane underneath the bush so that it's not sitting on an angle, effectively not making full contact with the surface of the pattern. And the way that that looks, if we look on this model, is a small round plateau on any of the angled areas. Now, if you do have any flat sections of mold, it's no problem. You don't need to add these features in that instance. It's just when your bush would otherwise be sitting on a sloped section of the pattern. So we'll start to sketch on the top plane, and then I'm going to draw in a 6.1mm hole, and that's going to be for where the dowel pins will be located. Now, 6.1mm is generally going to give you the best fit for a dowel pin, but it is worth experimenting on a bit of scrap material if you are going to be machining these to make sure that you've got a nice, tight, close fit onto your dowels. Sometimes, depending on your machining strategy and your particular tool selection, it can vary a little bit, but I find 6.1mm is normally where you want to be. Along with that one, we're going to add in another circle onto here at 18mm, and that's going to create that flat plateaued area. So in terms of location on these, You don't have to be incredibly precise with it. You can pretty much do this by eye. You're looking to get them fairly close in onto the edge of the pattern within around 20-25 millimeters, as that's going to ensure that that edge itself does clamp very, very tightly. In terms of spacing, that's really going to depend on what your particular molds are likely to require in terms of accuracy for alignment. I would normally say for a part like this, anywhere between sort of 75 millimeters and 100 millimeter spacing is fine. I'm just going to locate 3 in each of the corners of this mold. So we'll just select that, and we'll just by eye place these in. Of course, if you did want to, you can go to town on this, you can dimension them all in, but generally just doing it by eye is going to be adequately accurate. I'm just running these on one side of the component because I'll just mirror these features later on. So we can now look at extruding these features into the mold surface that we have here. These need doing individually because they're all going to be done at different heights. So we'll just go extrude, and we'll take both that and the hole and draw it down. Now, if we just take a side view on this, you can see that we've got quite a lot of height here. We want to bring this level down as close as we can to the surface here. You don't want them touching, so you just want to just keep them slightly proud. So in this case, I'm just going to offset the distance here by around about, by the looks of it, 6 millimeters. No, let's try 4. That looks about right. And then the other thing we're going to do is put in a taper angle. Again, we don't want these to be locking into the molds, so we'll put quite a generous 30 degrees onto that. And then finally, we'll just select join. That's just added that feature into our mold. So we'll just continue on and do the same thing with the other ones here. We're now going to mirror these features over onto the other side of the mold. Before I do that, I am going to convert the other side of the mold, that body, into a component. For some reason, Fusion just likes to merge everything together if you do a mirror operation. So we'll now create a mirror. We'll use features. We'll select all of those extrusions that we've just done, and our mirror plane is the X-plane there, and click OK. So we now have all of those features in. What we're going to do now is add in the second half, or the upper half of the mold, and use this lower one to subtract from it. So we'll just go combine. We're using a cut tool. Our target body is the top tool here. The tool body is the lower one, and we're going to keep tools so we don't lose that lower half of the mold. So we now have our upper half, which we've just modeled. And if we hide that, we now have the upper half with the female side of those features into it. These features are currently size on size, meaning that those 30-degree tapers are exactly at the same diameter throughout. Now, you don't really want this, as any inaccuracy in your machining is going to mean that your molds are not going to accurately close and clamp together. So we are going to need to build in a little bit of free play, a little bit of tolerance into those sizes. So we'll go back to our lower section of the mold, and we're just going to use the press pull feature on the taper angle there. We're just going to remove 0.5 millimeters from it, and that's going to give us that little bit of extra tolerance that we need. So we'll just now go through and select all of the faces of those features. What we have at this stage is a model of the mold, not of the pattern that we need to produce the mold. So to flip that over, all we need to do is extrude another piece of stock through this. So we'll just select the lower face there, and we will draw a piece of stock through our component, making sure that we've got enough material on the other side to make a stable pattern. So we'll just draw that out to about what we've got there. So we'll create a new body and select OK. Now we're going to use the combine tool again. We're going to use a cut. Our target body is that new piece of stock. Our tool body is our mold. And we now have a model of the pattern. So we'll do that again. This is the lower side of the mold. We'll just repeat that whole process for the upper side of the mold. final thing that we need to do is add the bores for the dowel pins for the mould clamping bushes. So we'll bring up the sketch we drew earlier and we will extrude these through both patterns. And like we did before, just mirror that feature across onto the other side as well. So that's our fully featured patterns for producing our split moulds. These can now go on to be CNC machined. One thing to remember about these particular patterns is that they will also feature some removable shuttering that's attached around the perimeter. Now if I show you on this example what that looks like, so we'll just add these in. And these are just carbon fibre plates that are going to get screwed onto the outside of the pattern. And these form the 90-degree return flange all the way around the outside of the mould. Now it is theoretically possible to machine in these vertical features directly into the pattern, but as they don't have any draft angle, it's going to mean that the removal of your mould from the pattern will be almost impossible. So instead, these can be removed away from the outside and then the mould will easily release. The next stages for these patterns are to have the toolpaths generated in CAM software. In this instance, I'm using the inbuilt manufacturing facility in Fusion. The machining operation consists of a series of roughing and finishing strategies. Into the real world, before machining, the epoxy tooling board can be blocked out into the rough shape of the pattern and bonded using its matching EA700 bonding paste. Doing this not only reduces cost and waste, but also the machining time, and is one of the practical aspects of tooling production that we'll cover in a separate tutorial. The machining operation involves a few tool changes and takes several hours to complete. After this, any machining marks are then removed by hand. As with the single part mould, the pattern is then sealed with S120 board sealer before the moulds are laminated with the XT135 tooling prepreg. They're then vacuum bagged, oven cured, finished and release coated, ready for service. Hopefully that covers everything that you needed to know on designing patterns for composite moulds. While this has been primarily a CAD-based video, remember when it comes to realizing projects like this, Easy Composites stocks all of the materials and equipment needed to make your patterns, your moulds and your components. If you wanted further information on how you go from these patterns onto making moulds, then check out this video where we go through all of the details. If you've got any questions or feedback, we'd love to hear from you in the comments. From everyone here at Easy Composites, thanks for watching and see you next time.